Alright, welcome to helpyourmath.com. In this video we're going to be covering factoring, and in this case we're factoring quadratics with leading coefficients. Now this could be a troubling thing because there are a few ways to factor when you're dealing with leading coefficients, and there are three ways that really work effectively. The first of the ways is the grouping method, which if you watch our grouping video it indicates a lot of how to do the grouping thing. And then we have also the trial and error method. And both these methods are using the master product in conjunction with them so that you can factor these a lot easier. For the third one, we have the shortcut method, which is an improvised way to get to your factors a lot quicker with a little bit of extra work, and it takes out a lot of work while you're including this little bit of extra work. And for the final one, what we have here is we want to wonder which is the best method to factor the last set. And so let's begin with the first one. And what we want to identify with this first one is the fact that we don't have two prime numbers at the ends of this. And because the 4 is not a prime number and the 5 is, we want to consider using the grouping method, because what we want to do here is use the AC method, which is the master product. And our A term in this case is going to be 4x squared. So we're taking 4x squared and we're multiplying it by a positive 5. And what we get here is 20x squared. What we're going to do with this 20x squared is we're going to look to factor it to find two factors which multiply to make 20x squared, and they add up to 9x's. And in this case what we'll do is we'll just break 20x squared down to all the factors that are possible from 20x squared. And we have 1x times 20x's. We also have 2x's times 10x's. We also have 4x's times 5x's. And in the case of making a positive 20x squared, I'm also going to include the negative factors that are possible of this, which is negative 1x times negative 20x's. We also have negative 2x's times negative 10x's. And finally negative 4x's times negative 5x's. And we're going to write the sums of all of these products, right? And so we're just adding the two terms that are multiplying together. And what we're looking for here is the two terms that make this term of 9x, the middle term. And once we find that term, we're going to substitute the middle term with the two factors that we're adding up to create this. And so the first two, what we have here is 20x's plus 1x is 21x's. This isn't the middle term, so we're going to keep looking. 2x's plus 10x's, that's 12x's. 4x's plus 5x's, that's 9x's. This is actually the middle term. I'm going to complete this list though, just in case we have a different number. In the case they're negative or positive middle terms, we want to see what every possibility is. And there's a good correlation between the results on both sides of these, right? So here we have negative 1x and negative 20x's, which is negative 21x's. Negative 2x's and negative 10x's make negative 12x's. And negative 4x's and negative 5x's make negative 9x's. Since in this case what we have is 9x's, what we're going to do is we're going to substitute 9x for 4x's plus 5x's. And in the case we had like negative 9x or negative 12x, we would substitute the other pairs that we see here accordingly. So in this case we have 4x squared plus 9x's plus 5. And so what we're doing is we're substituting the 9x's for 4x and 5x. So we're going to split this into two cases. So we have 4x squared plus 4x's plus 5x's plus 5. And it doesn't matter the order that this is placed in. I'll show you guys that in just a second. But for right now, let's use the group factoring method, since this is the grouping method, to break down whatever's left over. So we take the first two sets and the last two sets and we see what they have in common, right? So here we have 4x's in common. What's left over is x plus 1. And in the second set, what they have in common is a positive first, because the third term is positive. We're going to factor out the 5 they have in common, and whatever's left over we put in the parentheses. Here we just have x plus 1 left over, and now we see the x plus 1 is the common term. We factor that out, and what we have left is just 4x plus 5. Now, a lot of people usually ask what happens if you rearrange this in a different way. And what happens is nothing changes. Just the factoring method changes a little bit, but nothing out of the result comes any differently. So instead of putting 4x's and 5x's, we're going to put 5x's and 4x's, just to show that it doesn't matter which order you put this in. And what these two have in common now is just an x, right? So when we group these two and these two, The x comes out. We have 4x's plus 5 left over. And these two have no common factors except for 1. We have to always remember that whenever we see two terms that have nothing in common, they still have 1 in common because 1 is a factor of everything. So we're going to put a plus 1 here because the third term is positive. And what's left over is just 4x plus 5 again. Now we see the 4x plus 5 is the common factor. And what we want to do is factor out the 4x plus 5 and multiply that by the last two terms here, the x plus the 1. And the order doesn't matter for when you're doing this. So x plus 1 times 4x plus 5 is the same as 4x plus 5 times x plus 1. And here we see that the grouping method works either way you do this once you find the master product and factor the terms and find the terms that sum up to the middle term. All right? So let's move on to the next one, which is the trial and error method. Now to do the trial and error method, what you have to identify with is the fact that you have two prime numbers on the ends of this. That's the best case for using the trial and error method because what it means is there are only two possible ways to make 2y squareds and only two ways to make positive 5. And so then we explore the ways to make all these terms and put them in conjunction with the middle term. Now we have to remember this is a middle term that's a negative term. And so we have to play around with the factors that make the two values. In other words, if you've watched the other factoring video which discusses when you have a plus minus plus, we know that the two terms for the ends of the constants of both factor sets have to be negative because a negative times a negative makes a positive, but they sum up to a negative term. So we'll explore this. So what are the factors of 2? 2y squared is either 2y or 1y. For positive 5, we either have a plus 5 or a plus 1, or if it's not this set of things, it's a minus 5 and a minus 1. And in this case, we know we're dealing with the negatives because the middle term is negative. All right? And so what we're going to do is we're going to exclude the positive terms because there's no way that we can have a sum of positive numbers. So we're just going to focus on these negative 2 terms because it's the only way we can create this negative 11. And so then what we're doing is we're trying to figure out which way we're going to multiply these to create negative 11, right? And it's negative 11y. So if we do 2y's times negative 1 and 1y times negative 5, the results we get are going to be negative 5y's and also just negative 2y's. And when we sum this up, we get negative 7y's. And that doesn't work out for us. So what we want to do is try this again and rearrange the factors. So what we do is we put the 2y, the 1y, and we're going to switch these around. We're going to put the 1y, the negative 1 up here and the negative 5 down here. We're going to cross them again. And the reason why we're crossing them is because these are actually pairs. So if we factored these in pairs and we multiplied, we'd be multiplying the 2y by the negative 1 and the 1y by the negative 5. So in the same way, we're going to troubleshoot these. And what we're going to get then is 2y by negative 5 is negative 10y's. And 1y by negative 1y is negative 1y, which adds up to negative 11y's. And just from this alone, we see that we have the middle term, and there's nothing else to do except for listen the results of the factors for these. And there we have the perfectly factored pair for the trial and error. Now, if you're doing this without using the cross multiplying method, another good way to see this is just to list them out. So again, the possible factors for 2y squared are just 2y and 1y. And the possible factors for positive 5 when the middle term is negative is both either negative 1 and negative 5 or negative 5 and negative 1. And so what we want to do is troubleshoot them the same way the cross multiplying method works, which is technically the same thing if you look at the factors multiplying here. Right? We have 2y minus 5 and y minus 1, which is here. 2y minus 5 and y minus 1. And also we have 2y minus 1 and y minus 5 up here. So let's start with the bottom one here first, just to check the middle terms. And remember, the middle terms are the product of these two and the product of these two in sum. And so when we have 2y's times negative 1, we get negative 2y's. And negative 5 times 1y is also negative 5y's, which gives us a sum of negative 7y's for the middle term. And we know this isn't the middle term because the middle term is negative 11y's. So we troubleshoot the final possibility in this case. And what we have here is 2y's by negative 5 and negative 1 by negative 1 by 1y. And 2y by negative 5 gives us negative 10y's. And negative 1 by 1y is just negative 1y. And that adds up to negative 11y, which is our middle term. And so we know already the factors are exactly as we said before. We have 2y minus 1 and y minus 5, which is exactly what we have here. All right? Now moving on to the shortcut method, which works a little differently than both of these, but has a collaborative effect of what both of them do. We'll take a look at how using the shortcut method works. And the shortcut method is a different auxiliary way to do this kind of problem because it uses a little bit of difference in what you're doing to compute what you have. However, it does use the master product. And so what we want to do when we're looking at this is see how this is used and when it's most effective. So in this case, we see we have a prime number and a number that is not a prime number. And so in cases like this, this method usually works very well because it's a very short end of doing a lot of work. However, it does incorporate a lot of different things that you would have to learn or adapt yourself to as you're doing it. And so in this case, what we're doing is we're looking at the leading term. And the first step we want to take before we begin any other process is take this leading term and place it in 3 places. So usually when you're doing factors of terms like x squared plus 4x plus 4, and you just open up 2 set of parentheses and put an x in each term, in this case we're doing something very similar. In this case what we're doing is we're taking the 3 and we're applying it to the x everywhere we see it. So we're putting 3x, we're multiplying it by 3x, and the major problem we have here is when we do 3x times 3x, it becomes 9x squared. And so instead of just stopping here, we're also going to divide this by that leading coefficient, 3. The second step we want to take is taking the master product of the 2 terms. And so we're taking the a and we're taking the c and we're multiplying them together. So we have 3 and negative 4, and this becomes negative 12. And what we're doing is we're looking for the factors of negative 12 that add up to negative 1. So we're going to list all the possible factors of negative 12. We have negative 1, positive 12, negative 2, positive 6, negative 3, positive 4, negative 4, positive 3, negative 6, positive 2, negative 12, positive 1, and we're looking for the ones that add up to the middle term. In our case, we have negative 1 as the middle term. Again, it's always useful to check into the inside of what all your possible sums are, because in the case you have a different problem, this would be the way you truncate which is the solution for what you're doing here. And in this case what we're doing is just adding them. So we have positive 11, positive 4, positive 1, and what we're going to notice is these results, when we change from negative to positive, repeat themselves in opposite terms. So here we have negative 1, here we have negative 4, and here we have negative 11, which are the opposite terms of what the first set created. Again, what we're looking for is negative 1, and so we're taking this negative 4 and the positive 3, and we're inserting it right in here. So what we do is we put the minus 4 here, we put the positive 3 here, and then we look to see if there's a greatest common factor. Since the 3x plus 3 has a common factor, what we're going to do is we're going to factor out that greatest common factor, which is a 3, and we're going to just put the result of when we factor out here what's left over, right? So 3x plus 3, we factor out 3, we're left with x plus 1. And we place this over 3, and the 3's just go away. And easily we just solved our factoring for this problem, which makes it a little easy. There's a little extra step, but the factoring, very straightforward once you use the greatest common factor. And it's a very effective method. However, now, we have this fourth problem. And what we're going to do with this fourth problem is determine which method we should use and which is the best method. And the truth is, there's technically no best method, right? The best method is always going to be what works best for you, what's most effective for you. However, being that we have 3 different methods, we're going to also talk about when is the best time to use which of these methods, right? So for the last problem we have here, which is 2x squared plus 5x's minus 7, what we want to do is determine which of these work best. So we're going to do each one of these and see what the workload is. So what we're going to do here is I'll just wipe this off. And we'll begin with the grouping method here at the furthest left. We'll use the trial and error method for the second, and then we'll use the shortcut method for the third. And this way we could see the effect of each one of these as we're working them out, right? So using grouping, what we want to do first is use the master product, right? 2x squared times minus 7. That's going to be negative 14x squared. We're going to look for all the possible factors of negative 14x squared, add them up, find the middle term, and use grouping, right? So we have negative 1, positive 14, each with an x, negative 2x's plus 7x's, that's negative 14x squared. We have then negative 7x's plus 2x's, that's also negative 14x squared, and negative 14x's plus 1x. Let's add them up. We have positive 13x's here, positive 5x's, we have negative 5x's, and we're going to see the repetition of opposite terms, and negative 13x's. And the term we're looking for is positive 5x's. So we're going to use this to replace the 5x's in this so that we could substitute it and then just use group factoring. Again, it doesn't matter which order you're putting this in because it will fix itself, right? And so we have 2x squared minus 2x's plus 7x's minus 7. We're grouping again, first two with the last two. These are two separate sets, and the first common thing we have in common between these two are 2x's. What's left over, we have x and negative 1. In the second set here, since the third term is positive, we put the plus down. The common factor is just 7. What's left is x minus 1. Here we see the common term, x minus 1. What's left over is just 2x plus 7. And there's the grouping method. Now let's take a look at the trial and error method, right? See what happens with this one. Now with the trial and error method, since we see we have prime numbers again, and we have a product of the factoring set is going to be plus, plus, minus. We know the two factors of the last term have to be both minus and plus. So this makes it a little more difficult. The factors of the first term both have to be positive, so we have either 2x's. So for 2x squared, we have possibly just 1x and 2x. For negative 7, we have positive 1, negative 7, or negative 7, positive 1. So we're going to try to mix and match these to see which one works best, right? So we'll start with 2x and 1x. And here we have positive 1, negative 7. The second set we also have is 2x and minus 7, and 1x and plus 1. And we see which one of these gives us a middle term that has a positive 7 on it, a positive 5 on it. And also, wait, I actually made a mistake here. Let's just go back a second. These factors are actually the same. I meant to put here negative 1 and positive 7. All right? And so the second possible way this works out is 2x minus 1 times 1x plus 7. Now these aren't the only rearrangements we have for these sets, because we could also pair the 7 with the 2 or the negative 7 with the 2. All right? And so there are going to be 4 possible ways to do this. So the other set is going to be 2x minus 7 times 1x plus 1, or 2x plus 7 and 1x minus 1. And that's because there are 2 set of factors for this set, and there's only 2 factors. There's 4 set of factors here where we have 2 and 2, and a set of just 1 for the first one. And we have to mix and match each one carefully to make sure that we have all the possibilities. Now when you're doing this, since we know 2x times 1x is 2x squared, and 1 by negative 7 in any case of these all produce negative 7, the only thing we're looking for specifically is the middle term component. So when we do the middle terms, the outsides and insides multiplying, what we're looking to make is this 5x. And so here we have 1 times 1x, and we have 2x's times negative 7. So we'll start with the outside. 2x's by negative 7 is negative 14x's. and 1 by 1x is just 1x, which gives us negative 13x's. So we know this is not the way, right? Because the middle term is not equivalent to 5x's. So we'll continue troubleshooting these. We have negative 1 by 1x and 2x's by 7, which give us the 2x by 7 gives us 14x's. And this one here gives us negative 1x, which adds up to 13x's. And the same way as this, they just produce opposite signs, which indicates to us we're nowhere near the right answer. And what you want to look for is either the opposite sign of the right number you're looking for. So a plus 5 or a minus 5x will give us a good indication that we have the right terms, but the wrong signs. And so here, when we continue, we see we have 2x's by 1 and negative 7 by x. And here we have 2x by 1 is just 2x's. Negative 7 by 1x is negative 7x's. And here we see we have negative 5x's. We're looking for positive 5x. So we know that we have the right magnitude, but the wrong sign. So usually in these cases, we just have to switch the signs. And so in this last case, we have 2x's by negative 1 and 7 by x. So 2x by negative 1 is negative 2x's. 7 by 1x, positive 7x's. And so when we sum these up, we get positive 5x's, clearly indicating to us that we have all the terms we need. The possible factors for this are exactly 2x plus 7 and x minus 1. And that covers our trial and error method. And for our final method, what we'll be using, which I don't need much space to do, I'll just take this little corner down here, is the special shortcut method. And so we have 2x squared plus 5x's minus 7. The first thing we want to look at are 2x squared plus 5x's minus 7. What we want to first do is set up the parentheses. Again, we put 2x in each set of parentheses because the leading term is 2. And the next thing we want to do is take the master product. So we have 2 by negative 7. That's negative 14. And the factors are negative 14 that add up to positive 5. So again, we have negative 1, 14. We have negative 2, 7. Negative 7 and 2. And negative 14 and 1. And the correct one for this, we'll just add them all up. We have positive 13, positive 5, negative 5, and negative 13. The correct one is going to be negative 2 and positive 7 because it's plus 5. So we put the minus 2, we put the plus 7, and what we're going to do is factor out the greatest common factor, right? So 2x minus 2 has a factor of 2 in common. What we have left is x minus 1. We have 2x plus 7 left, and that's all over 2, and the 2's perfectly go away. And here we have our factor set, x minus 1, 2x plus 7. And so it's up to you to decide which way works best for you, but do learn all three of them because they're all very useful, or at least the trial and error and the grouping method. Thank you.